Cincinnati and getting her master's degree, wants to be an educator. And this is sort of her student teaching portion. So I want everybody to give her your full attention. I don't want you studying for other tests, okay? I don't want anybody on their phone, all right? And so I'll take your abdomen homework that you have too. And then Lindsay has a handout for you, and she has a flash drive, so it's all set to go.
I apologize if I would have known how she was going to print it. I would have suggested to do it the way you guys normally get it with the notes. But now you have all the images. Okay? So think of it like that. That's a good thing. Positive. I know. I'm sorry to give you so much paper. Right. There you are. You're welcome. And I already found a typo, so everybody, on slide 32, I changed it on my projection one, but slide 32, the very bottom sonographically, cis may be singly, should be single or multiple. Just one letter, not too bad. Alright. Normally I would walk around a little more, but we got the projector right there and click. So, you guys already read chapter 8, right? You're ready to go. Alright, well like Susan said, I'm Lindsay. You guys have seen my face around, and I really like that I was able to kind of sit in on class at the beginning, and then I'm able to actually give you guys some information too. Maybe incorporate a little bit of pediatric stuff, but I know you're not being tested on that, so don't freak out. Don't worry about it. It's just for your knowledge. Alright, so embryology. Where does the spleen come from? Develops from mesenchymal cells, which are between the layers of the dorsal mesentery of the stomach. And you'll learn a lot more about this in OB. Don't freak out about that either. You'll learn a lot more from Rachel next year about that. The cells differentiate to form the splenic pulp, connective tissues, and the splenic capsule. Those are the three main things that the spleen is going to be comprised of. Sorry. Okay. Right thing, right? Splenic anatomy.
It's very slow.
Yeah, I don't know what's going on.
Coming back.
It's not like matching up here. Let me see. Sorry, guys. Okay. Alright, here we go. Splenic anatomy. It's the largest reticuloendothelial organ. It's not a vital organ. It's also the single largest mass of lymphoid tissue in the body. Deals with the blood formation in fetal life. And it's hematopoietic, which literally means blood producing. It's not, it's intraperitoneal, which means it's, good job, okay, good. It's a peritoneal structure, yep. And all except for the splenic hilum where the vessels come in and out of the spleen. And it's located in the left upper quadrant, and it enables sonography to visualize the left hemidiaphragm. And the reason why we wouldn't be able to see the left hemidiaphragm normally without the spleen, because the lung is filled with air, which we can't see through. So that's one good thing that we can see with the spleen as a window. And it's an encapsulated organ, usually shapes that you would think of it to be called as orange segment or triangular. I've also heard tetrahedral. Yes. It's kind of a fancy word. Alright, let's see if this works here. Alright, relational anatomy. What's around the spleen? What do we need to look for? So superior to the spleen, obviously the left hemidiaphragm, anterior, stomach, medial, the left kidney, splenic flexure, the colon, and the pancreatic tail. Remember how the pancreas sits in the body, so it makes sense that it dips down a little bit. You're going to see it close to the spleen. And then posterior is going to be diaphragm, pleura, left lung, and your ribs. So real quick, looking at your Kawamura diagram here. Again, we can see in the first image, superior to the spleen, which is kind of tucked back in here. You can kind of see it here. We have the diaphragm, the left kidney diaphragm. Anterior, going to be the stomach. You can kind of see how it's shadowed out here a little bit. Here's the spleen back here. Medial, left kidney, splenic flexure, the colon, and the pancreatic tail. I think this is a really good image. You can kind of see how the pancreas comes around. Here's the spleen right here. And posterior diaphragm, pleura, and the left lung. You can see how the diaphragm kind of comes down the posterior axis of the spleen right here. And again, I really liked this image. I know it's not in your textbook. This was from the Hagen and Answer textbook. But it really gives you a good idea, because in ultrasound you're always going to be looking at sections. You really have to get your mind into thinking, what am I going to see when I pull out that slice and look at it to get your relational anatomy. So again, to think about what's superior, anterior, and medial. Superior to the spleen, which obviously we can't see here because the layer that we're in is the diaphragm. And then anterior, we're going to see the stomach. Here's our spleen. Anterior stomach, spleen, posterior stomach. Medial left kidney. Right here, medial to the spleen. And also the splenic flexure of the colon and the pancreatic tail. See that again. And posterior diaphragm, pleura, left lung, and the ribs. So can you guys all see that image pretty good in your slides? Why is this going so slow? Sorry, guys. Come on. Okay, we're good? All right. Blood supply. What feeds spleen? Splenic artery, obviously. Branches from the celiac axis. And the splenic artery is actually the most tortuous vessel in the abdomen. It's definitely a good fact to know. And what else comes off of the celiac axis? You have splenic artery and what other vessel? Good. Orthopaedic. And it runs along the superior border of the pancreatic tail and body. You can see our image here. Comes off. Comes kind of the superior portion here and then enters into the spleen. And one thing about the splenic artery that's different when you think about the spleen versus the liver is the arterioles pass through the splenic parenchyma, so you don't have a lot of branching as you would in the liver, where you have different hepatic artery branches. So therefore, with all these arterioles that kind of diverge and go into the spleen, it makes it very susceptible to infarction or tissue death, because it just doesn't have that adequate same blood supply as the vessels branch out like the liver does. Alright, blood supply, when we talk about the spleen, splenic vein. This will be the vessel that you will see the most often in scanning, usually due to portal hypertension, because everything starts backing up. And it exits at the hilum, comes out, joins the S and V at the confluence to form the portal vein. So, I know are you guys used to thinking about the venous flow versus arterial flow yet, or it's all backwards? So the splenic vein comes out, meets up with the S and V, and then goes to join the portal vein, which then goes into the liver. And the IMV may drain directly into the splenic vein or to the confluence. You can kind of see it right here. So see the blue is a little bit more prominent in the caliber of the vessel. So it's usually going to be the one when you see a vessel, even before you put colorful on, you think, I bet that's splenic vein. But you always want a Doppler just to make sure. Alright, so what should our normal spleen look like? What's the normal size of the spleen? Usually about 12 centimeters in length, and they usually want to compare it, they say it's compared to that of your fist. If you think of your fist, that's about how big your spleen is, which is also about 150 grams, or I was like, okay, so how much is that? About a third of a pound, or 5.3 ounces. That's about how big your spleen is. It's not too big. It should be 12 centimeters length, 3 to 4 centimeters AP, and anything greater than 12 centimeters would then be obviously termed splenomegaly. I'm sure you guys have all kind of heard that term before. And in children, the size of the spleen actually correlates to age, height, and weight. So there's usually a chart or plot that you would actually plot your spleen size on, depending on the child's age or weight and everything like that. Here's our pictures of our normal spleen. I don't know if you guys can see this, but these are actually images that were taken from children's. This was probably a child that was quite a bit older. And how you would take your measurement of your spleen, you would kind of come from the farthest portion here and go all the way up to this border here to get the longest measurement. Then in transverse, and the one thing that's hard about measuring the spleen is that every technologist could be a little different on where they place those calipers. So a lot of it depends on the department that you're in, how they want you to do it. If they say, well, we always go here to here, it's like measuring the liver. Every department, some departments don't even do it because there's so much varying degree in technologists when you measure it. Then again, pretty normal spleen. Alright, the composition of the spleen. Earlier we said pulp that is made up of splenic pulp. So now the pulp is divided into two different types of pulp. The white pulp and the red pulp. The white pulp is going to be the lymphoid tissue. So a way you can remember that, you think, okay, aids in the immune system, lymphoid tissue, white blood cells. White pulp. Red pulp, reticular cells. Talks about blood formation. So white pulp, lymphocytes, helps with the immune system. Red pulp, reticular cells. And the pulp material is actually very spongy, soft and friable. So it unfortunately can get injured quite frequently because it's so soft. The physiology of the spleen acts as a reservoir for blood. The white pulp function is the defense against disease, production of lymphocytes, plasma cells, and antibodies, phagocytosis of bacteria. You guys remember what phagocytosis means? Eating, good job. I actually found this interesting. The word phagocytosis is the ingestion of bacteria, other material, literally means to devour. And phagocytosis from ancient Greek phagon, meaning to devour. Kytos meaning cell, and osis meaning process. So literally to devour, cell, process. That's kind of interesting. The red pulp function is the filtering of the blood. You have the culling and the pitting, and then hematopoiesis. Those are the three things that the spleen will do. The culling is the removal of the abnormal aged red blood cells, and pitting is the cleaning of the red blood cells, and then it returns them back to the bloodstream. Hematopoiesis, the blood formation, is just RBC production, only happens in